Okay, so we're going to do 9 minus 5 2/3. How I like to do them is I like to stack them. So I'm going to rewrite my problem. And I noticed that this doesn't have a fraction for me to take anything away from. So I could convert this into an improper fraction, this one into an improper fraction, and solve it, but I like to borrow because I think it's a quicker, less step, less difficult way, but that's just for me, so you're going to do what you're most comfortable with. So we're going to borrow from here, and when we borrow, we're going to take out a whole. Well, what is our whole? Our whole is going to be 3/3, and we know that because our denominator is 3, which means all of our wholes are going to be in 3 pieces. So we borrow a whole, which looks like 3/3. In this problem, we don't have to add this to anything, so we can just solve it. So we go 3 minus 2 is 1. 3 minus 3? No, we don't do that. We just bring down the denominator, and then we go 8 minus 5, which equals 3. So I stop and I observe this because this is my final answer, and I notice that this is a unit fraction, which means it's in its simplest form. So this problem equals 3 1/3. We're going to solve this with turning into an improper fraction. First, I'm going to rewrite it. So I'm going to change this one into an improper fraction first, since it's already in fractions. I go 3 times 5 is 15, plus 2 is... Then I have to turn this into an improper fraction. Well, I'm going to have to multiply it by 3, because that's what our denominator is. 3 times 9 is 27. Then I'm going to go 27 minus 17, and that is 10 all over 3. Now I'm going to have to convert this, and I have to go 10 divided by 3. And I go 3, 6, 9, 12, and I can stop there because 12 is bigger. 3 goes into 1 how many times? 3 goes into 10 how many times? 3 times 3 is 9. 10 minus 9 is 1. Good remainder. That becomes our numerator, and 3 is our denominator. So this equals 3 1/3. Now that I have that answer, I'm going to observe this. And what do I observe about this? This is a unit fraction, which means it's in its simplest form. So this is our championship answer. So the first thing I'm going to do is rewrite this problem. Then I'm going to observe it. What do I observe? The denominators are the same. We're subtracting, so I can solve this problem. But I can't take 4 away from 5. So I'm going to borrow. This becomes a 5. We pull out a whole. Our whole is going to be in sevenths, and we know that because of our denominator. So we're going to add 1 whole to this fraction. Now we're going to rewrite our problem over here. So we have 5 and 7 plus 1 is 8/7 minus 4 and 4/7. Can I solve this problem? I look and I can. I'm going to go 8 minus 4 is 4. 7 minus 7? No. We just bring down the denominator. Then I'm going to subtract whole numbers. 5 minus 4 is 1. Then I observe this problem. What do I observe about this problem? Well, 4 can't go into 7 evenly. 4 is not prime, but the factors for 4 are going to be 1, 2, and 4. And none of these except for 1 can go in here. So this is my championship answer. I'm going to do this problem converting it. First, I'm going to line them up. Then I'm going to convert them. I go 7 times 6 is 42 plus 1 is 43/7. I observe that I'm not going to have to change the denominators. I go 7 times 4 is 28 plus 4 is 32. Can I subtract 32 from 43? I can. I'm going to drop down my denominator because a golden rule says I never add or subtract. And I'm going to go 43 minus 32. 3 minus 2 is 1. 4 minus 3 is 1. We get 11. Well, we're going to have to convert this. So we're going to divide 11 by 7. We're going to do the multiples. And we're going to go 7, 14. We can stop. 7 goes into 11 how many times? 11 minus 7 equals 4. Good remainder. 4/7. This is our championship answer because we know the factors of 4 are 1, 2, and 4, and only 1 goes into 7 and 4. So the first thing I need to do is observe this problem, and what do I observe? This problem is subtraction. The denominators are not the same. That's a unit fraction. Maybe I'm also noticing that this is an improper fraction. Do you think I should get rid of this improper fraction before I solve it? I think I should, because if it's improper, that means that there's whole numbers in it. So we're gonna think, how many times does 2 go into 4? It goes in there 2 times. So 4 halves equals 2. Now I have 6 1/8 minus 2. Can I solve this problem? I can. So I'm going to go 6 1/8 minus 2. Well, I don't have a fraction here. So am I going to have to do anything? No. So I'm just going to go 1/8 minus nothing is 1/8. 6 minus 2 is 4. I stop and I observe this problem. This is a unit fraction, which means it's in its simplest form. So this is my championship answer. Do you see why observing this problem first helped us? Otherwise, we would have turned this into 8s. And we would have went times 4, times 4. Then we would have had 16 8s. And then we would have had to borrow a bunch, or we would have had to convert this into an improper fraction. Whereas if we observe this first and change it into a mixed number or a whole number, then we have an easier, a simpler problem for us to deal with. So we always want to make sure we observe and think about, can changing these things help us?